So if you want to find the fundamental unit as a fundamental vector for a vector, so if we have m vector represented by ordered pair x and y, so we can write m vector equal ordered pair x and 0 plus ordered pair 0 and y from definition of addition. So we can write x multiplied by ordered pair 1 and 0 plus y multiplied by order the pair 0 and 1. So x multiply 1 and 0, it's mean x and 0, and 0, y multiply by 0 and 1, it's mean 0 and y. So we have 1 and 0 is I vector, so it will be xi plus y multiply j vector. So we can write any ordered pair x and y in fundamental vector form as xi plus yj. So we have the norm of m equals root x power 2 plus y power 2, as we said before. I have an example. If we want to express vector m, each of the following vectors in terms of fundamental unit vector. So in fundamental unit vector, we use I and j. So we can write m 2 and 7 ordered pair by 2. This is I, 2i plus 7j. And vector n 4 and the negative 3. So we can write 4i and 4i minus 3j. Vector L, we can write it negative 5i plus 0j, which is 0. And last one Z, we can write it 0i plus 3 over 2j. Is 3 over 2j. Example, find in terms of two fundamental unit vectors a vector which expresses each of the following. The uniform speed of a car covered 90 km per hour in the east direction. Letter B, a force of magnitude 50 newtons acts on a particle in the direction 30 north of the east. So solution, we have the first one, the uniform speed of a car covered 90 km per hour in the east direction. So the x-axis in a positive direction of x-axis represents the east direction. So we have here 90 km, we can write by vector or directed line segment OB, which is represented by x and y. So x equal 90 and y equal 0 because we move in horizontal line. So we can write the vector B as 90i plus 0j, which is 0. So the vector B represented by 90i. Second one, a force of magnitude 50 Newton acts on a particle in the direction 30 north of east. North of east, it means the angle which make with the x-axis will be, positive direction of x-axis will be 30. So we have here OC represented by ordered pair x and y. So if you want to find coordinate of x and coordinate of y, we use the rule of the polar form. If we want to find x, so x will be 50, the norm multiply cosine angle 30. The x coordinate will be norm of OC multiplied by cosine theta, which is 30, and y norm of OC multiplied by sine theta. So 50, norm of OC 5 newtons, so 50 multiplied by cosine 30, which is equal 25 root 3. So the x coordinate 25 root 3, and y coordinate 50 sine 30, which is 25. So in fundamental form, we can write C as 25 root 3i and plus 25j. So vector C, we can write it in the fundamental vector form, 25 root 3i plus 25j. And we have Important example, the following figures show representation of some vectors in the orthogonal coordinate plane. Write each vector in terms of the two fundamental unit vectors, two fundamental unit vectors, which mean I and J. So the first one, E, we have the positive direction of I is the positive direction of x-axis, and J is the positive direction of y-axis. So the direction of A is negative, so will be negative 4i because we move 4 units left. So we have 1, 2, 3, 4. So negative 4i. And second one, B vector. B vector is vertical, so we use the fundamental vector J. So it's in the opposite direction of the positive, so will be negative, and we move down 1, 2, 3 units, so will be negative 3J. And C vector, we can represent it by, we have C vector represented by the horizontal line and vertical line in x-axis and in y-axis. So the direction from this point, so we'll start with this, the horizontal line, the direction of the horizontal line, then we move up. So we have here the horizontal line, or the horizontal vector, 1, 2, 3, 4. So it's 4i, and up in the positive direction also. So 1, 2, 3, 4, 5, 5j. So we can write C as 4i plus 5j. And the vector D in the positive direction of y-axis, so 1, 2, 3, 4, 5, so represented by 5j. And we have vector K, so this is start, so we move down, then we move right to the end point of this vector. So we move down 1, 2, 3, 4, 5, so will be negative. So we'll take the first one, the horizontal, which is 1, 2, 3, 4, 5, 6, 7. So this is in positive direction, so it's 7i, and this is negative 5j. So we represent it by 7i minus 5j. And vector L in positive direction, and its magnitude 1, 2, 3, 4, 5. So represented by 5i. And we have vector M, the last one, vector M. So we have, this is the starting point. So we move left, then we move up. So we move left 1, 2, 3, 4, 5. So will be in negative direction, so will be negative 5i, and we move up 2 units, so will be 2j. Thank you for your listening, and see you later in the next video.